Hello and welcome to our webinar. Our topic today is stiffening design in RFEM 6 using our add-on building model. My name is Richard Hase. I'm working for Dlubal in the product engineering and in the customer support. And I will moderate today the webinar and answer your questions. And my colleague Bastian will show you the webinar today, but he can introduce by himself.
Yeah, thanks, Richard. Yeah, my name is Bastian Kuhn, and I will do the presentation today. And after a short introduction from Richard about the used software, we will directly start.
Okay, then first we can deactivate our cameras.
Yes.
And yeah, if you have questions during the webinar, you see here this panel, and you can write your questions down there, and I will give you an answer. If we have the case that too much questions are open, then you get the answer later, or even you have the option to watch at the webinar and write after that an email to info@dlubal.com, and we also will give you an answer then later. Okay, that was introduced, and Bastian, you can start with the presentation for today.
Okay, thanks, Richard. Okay, what we are gonna do today, I will tell a little bit about how to create stories with the building model add-on. What I want to show you, I will show how to divide a 3D structure, actually the one that you see here on the right side, into slabs and shear walls. And in order to understand how the building model add-on works, I will also explain the comparing of a support reaction as load transfer. It's a little bit of a hidden function in RFEM 6, but in my opinion, it is perfect for understanding how the building model add-on works. Yes, and last but not least, I will show you the combination of the load transfer and the building model, because I choose this building that I'm using today because it's nearly perfect for showing the advantages of the building model add-on, but also about the function support reactions as load transfer, because it is smaller on the top. So the nine stories here on the top are smaller than the 3 stories in the bottom, and therefore you will, yeah, it is recommended, or in my opinion, it is the best way to analyze this bigger cantilever or balcony outside with this bigger area with the 2D analysis. And in this way I can combine 3D and 2D calculations. Okay, before I start to explain it via the software, via RFEM 6, I want to tell you just a few words about the project that I'm using. You can find the project on our homepage. I did not 100% model it the same way for today, but it is adapted to this building. It is in Amsterdam in the Netherlands, and you see, I mentioned it already, it is smaller for the 9 stories on the top. It is completely made of CLT. That's already a difference to what I'm showing you today, because I'm combining it a little bit with concrete in order to have a hybrid structure. Here you see the RFEM original model, and you will directly find out that the model that I'm showing is a little bit different, but it's, as I said, it's adapted to this. I used the same model in a previous webinar from the summer last year, from August last year, and you can also find it on our homepage under support learning webinars. It has the number 002965, and in this webinar I took a deeper look into the vertical load transfer and also in the dimensioning with the add-on timber design. And this is not today's topic. Today's topic would be only to look how the building model works, how it works for stiffening the elements, how the load transfer works. This is the aim of today's webinar, and I hope I will be able to show that all to you. All right, now it's the time to jump into the program. Maybe take a short look. Any questions so far? No, that's good. So this is the structure. As I said, it's only the smaller part of the building, from story 4 to story 13 has a complete height. So this part of the building has a complete height of 27.5 meters. It has a length of 19 meter 20 and a complete width of 6 meter and 70. Maybe we also take a look to the ground floor just in order to understand how the building works. You probably did not watch the previous webinar, or not everybody of you watched the previous webinar. As I said, it is made of CLT. So I have 3 slabs of CLT attaching here. Maybe if I show the nodes, we can also give you an estimation of which dimensions of the CLT plate we are talking. So each of it has a length of 2 meter and 40. And this is because it would be possible to produce a CLT plate with a length of 6 meter 70, but it would not be possible to bring it to the assembly, to the building site. And that's the reason why in the practice this is always transferred into several pieces. And in order to regard the connection in between, I modeled here a line hinge, or this is also in the original model that you can download in the customer project from our homepage here with the stiffness that I calculated, in order that the structure is not collapsing, because obviously when we look in X direction on it, if you put on load in here, I can also show the load in here, and you have no support, no downstand beam, it's clear that this will collapse on this, because there's no moment rotation, it's not moment stiff in this direction for this load behavior. Okay, so this is the structure itself. You see that wherever there is a wall, there's a failing support underneath, which can only bear pressure contact, and I have a tie support at the end and the start of a wall, wherever a wall attaches. And here we have the concrete wall, which is quite stiffer inside, and yeah, here I have this walls attaching to it. Okay, maybe just so that you know, the CLT plates that I used for the slabs I took from the database. In here, did I click on it? Yes, I think so. And here in layers, I choose from a library. Well, I choose Derrick's, but I could choose any other producer. It's possible to use producers from all over the world in here. And when we get to the walls, I will probably open that again, because there's some special settings that may make sense to introduce also in here. Okay, the load I showed already. Every story has a loading of, in the first load case, of 2 kilonewton per square meter in here, and I choose the wind load varying here from the bottom to the top. It would have been possible, of course, to use our wind load generator, but I want it to be comparable with the 2D model that I want to show you afterwards. That's why I'm using the simplified approach. Of course, if you go into the load generator here in the load wizard for wind load, such a building is always possible to calculate with wind load, and then you have 16 wind load cases in every direction. It's regarding eccentricity of the wind load. All these effects can be regarded, but yeah, it makes it harder to analyze the load bearing transfer, and that's why I decided to use the simplified approach, which in my opinion is on safe side and therefore is good enough for this demo. Okay, this I can switch off the load now in here, and yeah, I mentioned it. Take a look at the slab or at the walls. Slabs we did. Maybe if I put this on and we can get rid of the node, it's looking a little bit better. The stiffness direction, I don't know if you saw that when I mentioned it on the ground. I have an option for the CLT plates to show the resulting stiffness, and usually walls in CLT plates, you always put the stiffness direction vertical, and on slabs, you put it horizontal. That's what this blue check should tell you. Here is the already mentioned concrete wall, just to make it stiffer and to show you that it's not 100% related or to timber. So the add-on building model is open for any material. And here is the staircase in there, and it's also concrete, and the walls are not connected to each other. So the CLT walls, I said I want to mention more in detail, or just the special function that you have in here. When you have a mainly wall loading behavior, you should be aware to activate this design for failure of net sections. I don't know, when we go to the library in here, yeah, there you will find even a better explanation of this. Maybe we can have a look at the, oh, it has to be on series calculation, stiffness. Let me take a look. I would just want a simple picture. Yeah, or maybe I'm not finding it. So maybe in stresses. Yeah, this one. You see, that's the torsional loading behavior, which is activated only if you have activated this check in here. So yeah, for the wall, that would be quite important. And ongoing, the load transfer for the stiffness of a wall should, for CLT plates, always be reduced by a factor, in this case 0.69 for K88. And in such way, every wall is bearing force in here. That's the point. It would be possible to reduce stiffness or also to exclude walls from the load bearing, but in the model that I'm choosing in here, every wall is taking the horizontal or transferring the horizontal force from the wind from the top to the ground. This yeah, and when we get specific to concrete, if you want to regard crack and or loosening of stiffness, it would also be, well, there are several ways, a whole bunch of options, but one of the simpler approaches would be also to use stiffness modification. Okay, so this is the building. Yeah, and when, yeah, in former times, before we did not have the building model add-on or this support reaction tool, customers always tried to calculate it this way. Let's say we have load case 1 with the 2 kilonewton per square meter, and we calculate it, and yeah, maybe we can remind just this little vertical force in here, 257. I can put it into my shortcuts also, so just that we remember it afterwards. But the problem always is when you do calculate such a structure in this way, it is not the reality. In the reality, such a structure would be assembled from the bottom to the top. And now you are calculating from the top to the bottom, which is, yeah, strictly or hardly said or roughly said, it's wrong. And you should not do it, or you should find a way to regard settling of the structure during the assembly. And what is when, yeah, a stiffening element is failing or whatever. There are hundreds of things you should regard, and when you just calculate the whole building, it can become extremely wrong. Okay, so now how would you do that? Of course, you can reduce stiffnesses, define line hinges, and so on that I showed you in the slabs in the start. All these possibilities you have, but it makes just the calculation very complicated. And this is actually where the building model attaches. So we will go to the building model, activate it, will change nothing else. And now that we did so, we have here in the structure, building model, right in the columns, 4 options to define building stories, floor sets, shear walls, and deep beams. We have the same functionality here in the data navigator, and we'll actually at first step define the building stories. Okay, I will put on the rendering and activate rigid diaphragm. Yeah, so the first story is already there. You see it knows, so the software knows it is located the first story from the origin 0 to minus 2.75. I can always choose any level elevation that I want. I get a mass. I get also a mass center. Obviously, where I'm having the concrete kernel, I have more mass, and that's why the mass center point is moved a little bit to the left side here in here, and afterwards it will also calculate us a stiffness center of the complete structure. So okay, I will do this now for all the other stories in here. So we have 9 stories in total in here, from story 4 to story 13. Here the top elevation, yeah. And now for all these stories, in order to regard settling, for example, settling or creeping of the structure, it would be possible to define different nodal support modeling and different line support modeling. Right now, and also in the 3D calculation that I showed you in the start of the building, every FE element has the stiffness of the material, E modulus with the thickness. This gives you the vertical stiffness of it, E by A. And yeah, of course, this, as I said, will not regard assembly points or effects. And if you define elastic wall hinge, for example, it will regard the vertical difference in stiffness, but also the horizontal stiffness of the wall. And that's actually what you did define whenever you calculate 2D models. I don't know in any software which is there on the market. And this is now possible to be regarded in this 3D model. So I would kind of call it 2.5D. That's what we're doing. We are calculating with the complete 3D building, but we're reducing it to 2D levels. We are dividing it into slabs and walls. This is what this add-on is doing. All right. Global settings is something what you can define whenever you want to story height modification is possible. Or if you say, because of my installation, I have openings that I maybe want to regard for the vertical load, but not for the horizontal, you can also ignore that. That may make sense and is, yeah, a brand new function, why I'm showing it to you today. Okay, now it's deleting the results. Of course, it's deleting the results. And apart from the mass, you see not really much in here. That's not so much happening. And you see, okay, every story has its own mass. Of course, the ground story has also this this bottom slab in here. That's why it has this this higher weight. Yeah, but that's actually it. But now when we activate the special object rigid links, I hope it gives you kind of an imagination what this is doing. So you see from the gravity point, from the mass point of the structure, we have a connection to every FE node here. So in this way, we are calculating 3 times, and we have now, as I mentioned, we have divided it into slabs and walls in here. This, maybe if I just go, no, I cannot go back. I should have showed to you before. But when we look for the ground floor, there the stiffness type of the slab is standard. And if you look for the stiffness type of the wait, I will get rid of the rigid links again. If we look for the stiffness type of the surface in every higher story now, you see that it is transferred into a floor slab rigid diaphragm. So for the horizontal loading, for the wind load in our case, but also for earthquake, for anything that's working horizontal, 2D second order theory effects and so on, you you will use this rigid diaphragm in here, just in the slab. And for the vertical force, we're using a load transfer. There's an option to choose isotropic and stripes. We will start with isotropics because I want to show you what effects you have when you are choosing stripes instead of isotropics in here. Okay, so now this is done, and I would like to explain it only by the self weight in here. Before we go to the wind load a little bit, I will also take a short look if there are remaining questions, but I'm pretty sure Richard will answer them all. Just opening them. Hold on. Okay, so far nothing remained open, and you see now it has divided the force here and calculating the first load case. And when this is done, when the force is divided and transferred to every story, it will do 3 calculations. That's quite of an important step inside. Yeah, generating the mesh afterwards. I hope we can have it soon. Otherwise, we would take a look. Oh, wait, there it is at the 2D position. So you see, there's a static analysis, the ordinary static analysis, a floor static, and a rigidity analysis of it. And if you have 3 calculations, it's clear that you have also 3 results of it for each load case, for each combination, for everything. And so if you go in here, it's no opening. We have the results, but here you see that this is my ordinary calculation that I have had before in here. Oops, maybe look on the side of it. So if we remain for the point that we put into the shortcut, so you see that is pretty much the same. Vertical load, that's pretty much, it is 100% the same. But when we look for the floors in here, you do not have any vertical load and or any vertical support reaction. That's probably better said. And here we have now only, oh, hold on. That is just a little bit strange because I did load it on every story. And to me, this does not look too good. Hold on. I think it's not connected inside here. Okay, there's a small problem that I'm facing that I don't understand. I had prepared the model before in a working position, and I would like to open this Apologize for this because this is not the result that I would expect in here. Okay, so here it is again. Sorry for this. And we now also have to wait again for this result. But yeah, as the mesh and the transferring of the load is already done, I suppose that I will receive better results in here. There was no connection from the top points to the other ones, and so this is was obviously not correct. I don't know. I will take a look on this later on. All right. So global deformation analysis. We look for the floors and hope that this is now better in here. Yeah, it looks way better. Yeah, perfect. That's actually what I wanted. So you see now that I'm looking for the floors, you only have here, and for the first load case, deformation in the floors and no deformation in the walls. The walls are in this global 3D calculation in here. And we will take a look on the walls in the load case 2 afterwards. But right now we will take a look to the floors. And when we activate the functionality surfaces and loads from distribution, you can see now here that I have a constant force in here, which is actually what we want. But when we switch back to the reason is because I changed this slabs already to the isotropic, from the isotropic to the varying point, and I would like to show you the effect again, what this is doing. All right, right here, so this, okay. Yeah, change this 30 surfaces and go back to the standard isotropic FEA stuff, and I will calculate only only the load case 1. Gives me time to take a look what the reason was that this is looking so strange. Maybe if I take a look into this, but this is all correct. And maybe I could also activate shear walls and deep beams. It's a function that is perfect for analyzing results, and maybe then it's connecting it correctly. Just to try for now till the calculation runs in the other model. Hold on. Okay. This, and this is something what you could use for directly defining reinforcement in here and also generate result sections. I will just show this to you on this shear wall in here. All right, to me, definitely good to delete the results here. And I also will define a deep beam where I have the opening of the building in here, where the staircase is. Therefore, I have to activate the surface cells because this would be good to be used by surface cells. So we go surface and surface sets, and we were using this here. And this can now be seen as a downstand beam. All right, say okay, and also maybe generate a result section. Say okay, and maybe also use this function in here to use load transfer X stripes right now. And here you see that that's what I choose before in the original or in the other model that I showed you, it's possible to use uniform load distribution. And when it's not uniform, we can take a look now on the other models. I apologize, it's now a little bit, maybe a little bit confusing, because I'm now opening already two models or two instances of RFEM, which was actually not the plan, but is how it is now. Okay, in this other model, we are transferring also the mesh and have also already the result in here. So this pretty much looks the same, but when we activate now the load, you can see, okay, it is now taken from the top story or slab, from the top slab to the slab underneath it. And you see now here, it is varying, which is not what we want. We want to have it constant here for our static analysis. It's what you always choose when you take a look at the support reactions. And here you also take them constant. Okay, let's just for comparison open this other one in here. Yeah, that looks now also better. So we can proceed with this. I don't know what went wrong there in the other model, but now it looks good, and we can start with go on with this. Okay, and in here we say now surface load from distribution activated. Get rid of the surface load. And we are in load case 1, and you see it has here now a constant value of 6.8. Okay, I want to open now a third or second instance where I want to show you how vertical load transfer works. Doing this, we will calculate also the wind load in here and jump now to the other model. This is a 2D model. It may not look as a 2D model, but it is, because everything that I did in here is that I just simply copied every story. There's no connection in between each story. That's from story 4 to story 13. With all the supports that you have in here, I have the same load. So load case 1 here, self-weight and wind. Again, also horizontal. And now, how would you do it in previous times to regard something like this? When you do not have the add-on building model, you would transfer the load from this slab to this. And this, of course, can be done via the function here, load wizard import support reactions. In here, you can go into the Dlubal center and say, okay, I'm connecting my story 13 from this all stories with this story 12 in here, and I can choose the supporting nodes, the supporting lines, and say, okay, please attach this force to this one. And then I can say, okay, here's it's the same as what we've had in the stripes and isotropic FEM method. Here you can also say I'm using uniform or varying, but at least for this webinar and for all the engineers that I know, they always want to use uniform loading. I myself also want to use uniform load distribution. And here you say, okay, I'm transferring from load case 1 self-weight to load case 1 in the other position. In this case, I only have vertical load, so I'm using only Z. And in load case 2, as I have wind load in there, I want to transfer all directions without moments in this case, because they are all hinged. I do not have any effects. And when you calculate this one here, do I have results? Oh, I have results. Here, and then hold on, switch off. Also in this model here in story 12, I have self-weight and also horizontal force. Hold on. Line loads. So you see they are here. And now when I look for load case 1, you see that I have here a value of 5.6, which is pretty much near what we have in the bigger 3D model. And when we look for the results in load case 1 in here, so you see that this value we have in here, 5.6 surface loads is the resultant here. And of course, you also have it on the story 12, 5.8, but as this is not regarding the load transfer from the top, this is already the error what you are doing here in this 2D model, because you are not taking the force from the story 13 to the story 12. This you have to do in this separate position. Okay, and it can work the same way with the wind load. So when we take the wind, as we did it here for the wind load case, and maybe again we look for the stir case for the concrete kernel, we have here a horizontal force, and here we also can activate the info box maybe, and maybe only visualize this in here. This is now this and this. And when we look for load case 2 in the bigger 2D model, this is this, hold on, do the same in here. You see that, yeah, 0.29 is the sum what we are having here as well. So this fits, and now this is taking this as a load, and the resultant of the horizontal is 1.2. You have to transfer to the story underneath, and so on. So you have kind of a 3D calculation in a 2D model, 2.5D. That's what I meant with this. A little bit hard to explain, especially when now that I've opened this several instances of it. Okay, and here in this model where we are using the building model, this is now perfect for analyzing such bigger structures. When we take a look at load case 2 and the wall, and maybe also the resultant, that would be something where this shear walls that I defined play quite a big role, and we're looking for section 1 and 2, because you see that in here you have the horizontal force of 5 kilonewton in total that goes through the wall, and here are introduced as a new loading to the story underneath. So this is how the load transfer in this add-on works. And whatever you define how the shear wall looks is up to you. When I'm saying, okay, this wall in here, for example, I don't want to bear any force, you can always deactivate it via the structure modification, or you can reduce the stiffness of it. So this would all be possible, but it is in this 3D calculation, but you are looking onto it only in 2D, on slabs and walls. So this is how you would do that. Okay. Okay, I hope I explained that. And as there are no questions to this, I think I have explained that correct. Or you understand this correct, what I wanted to explain. And I want to take a look on my notes, what is missing. Yeah, apart from this, how the load transfer works, you also have a lot of other functions that the building model add-on gives you, that I'm summarizing here. So you have, I would switch back to the load case 1 and switch off the load, and not results we will leave on. And we can activate the center of rigidity. So you see the mass center is right here where the staircase is with the concrete, and the stiffness, as this is also a concrete wall and I have a lot of walls in here and also in the center of the building right here on this side. So there are more walls working in horizontal direction. On this side, my stiffness center is moved to this point. And this is actually something when you are doing a dynamic analysis, which would also be possible with this add-on. It would regard your eigenvalue analysis due to the response spectrum method, and you would get the force in every story, and you could regard torsional effects by introducing load on the stiffness center, because if you introduce the load on this point via the eccentricity to the mass point, you can regard torsional behavior of the structure perfectly. In each story, you have that in each story. You have that this, here, here, and here. Okay, this is one of the advantages of the building model. We have vertical result lines. So you see graphically the horizontal force. When you activate it, you would have it. Okay, sorry. Where is it? Hold on. Here, this one, this one, this one. Yeah. So you have the horizontal force in here. Of course, on the bottom, it is you see the complete force that's going through the whole building. Also something that you would need for the dynamic analysis. And then you have an output via columns for the results of every stories. You get an X and Y coordination of the rigidity and of the mass center. You get the interstory drift in each direction between each story, also something that you need to calculate with quite a lot of effort when you are using this 2D approach that I showed in the other model. Where I defined the shear walls, I did it only exemplarily on this vertical wall in here. You have directly, instead of forces in a surface, you have directly member forces that you can use for your further analysis. You have the same for the deep beams, and here again you have it for the shear walls. You have sections where you can work with all these points. You can take a look on. Maybe if we go back to the load case 2 again. So for the wind, and we activate the shear force in the surfaces, and here in NXY, and now we are only looking at the walls, and we have quite a high NXY right here at this point. Maybe if we hold on, can I attach it? Yes, for sure I can. So here, 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 and say visibility by this objects in here. You can see, okay, load transferring is, as I already mentioned, is done by the surface itself. If you model it to have a reduced stiffness, if this would be a CLT wall, it would include the reduced stiffness. If you have defined a line hinge in here, that would be regarded. But right now I did do nothing with it. It's using this shear force in between, and that's the result that I have. Of course, I can always have my shear force integrated here, via the result beams. This is also done automatically by this add-on building model. All right. Yeah, this is the advantage. Let me take a look. I probably have missed some points, but I can't remember them now. Yes, one thing. If we cancel the visibility mode and take a look for the floors again, so you see also an effect. NXY in the floors is like nearly zero, even I have such a high horizontal deformation. Why is it the case? Because I'm calculating only 2D for vertical approach in this here. And if I go to walls, it's different. All right. Then whenever you have used visibilities, it's also nice that the building model add-on calculates you or generates you stories. So you can always say, okay, I'm activating story 9 and story 1. You always have it directly automatically generated and can work only in this specific story. So that would also be possible. I think that's all I have to say to the building model add-on. And now the last point that I want to show you. Now, if we go back to the homepage and take a look to the building, here I mentioned it, when there's such a point or such a critical point where a smaller building attaches to a bigger structure, it's probably necessary to do a deeper analysis on this special point in here. And how could you do that? In my opinion, the best way would be to say, okay, I'm combining or transferring the results from this big 3D model to the 2D, and therefore I choose this one. So this is the original building or the original structure, similar to what I showed you, but yeah, trust me, it's way bigger. And if you don't trust me, I can show you here, and it's having a higher length. Oops, that did not work. Why is it not working? Okay, yeah, it's longer. I don't know. You can see it. The original building or the building from story 4 to 13 goes from this point to this point and has this width. And now if we remember the resultant that we should take a look on when we started it, I just move it back in here, 257. That's the value we want to have. It is always possible to combine the results of a building model add-on with import support reactions. And this is nothing else what I did here. I choose the connected model in the Dlubal center in here. So I choose this one and say, okay, just for the demonstration here today, use this number 1553 and transfer it to line number 56. And again, transferred here. So, and you can see that this is now just, again, as a demo, transferred correctly to it. Okay, yeah, maybe a little bit confusing, but I hope you got it all. Otherwise, just give us a call and we will try to show you that more in detail and hope you can explain and see the benefit that this add-on will offer you. And I give the word back to Richard.
Okay, then can you give me the display?
Sure. Yes, they will.
Okay, moment, then I hope.
Confused by the video?
Yeah.
Oh, sorry, I can switch it off, no problem.
Wait, I hope you can see my display now.
Right now it's green.
Yeah, okay.
I hope. Yes.
The PowerPoint. Okay. Yeah. Okay, perfect. Yeah, then first, thanks, Bastian, for the presentation. And yeah, if you want to book your free online appointment for the building model or even other add-ons we have, please contact our sales colleagues over the QR code or over this link. And yeah, you will get a free demonstration from one of our experts. Okay, then I want to show you other free online services on our webpage. For example, the GeoZone tool. Maybe I can switch on our homepage here under products, GeoZone tool. Oh, I hope it open it. Or not logged in. Okay, one moment. Okay, again, GeoZone tool. Okay, I need to click there. Yeah, and for example, you want to know the snow and wind loads from London. You can switch or get informations about the load zones and see values. Yeah, that's one of our service. Then also we have big assortment of tables of cross sections, FAQs, and knowledge base about our products, models for inspiration you can download. This webinar will record it, and you can find it again, switch under news, events, webinars, and let me find, where is it? Somewhere here, and yeah, there you can click and find also our PDF document and the webinars. There will also be a link, or you go to our YouTube channel and can click here for an abonnent and get here information about the newest videos. And yeah, also you can try all of our programs 90 days free in full version. And okay, questions we don't have left. Okay, and yeah, at the end I would be happy if you comment our webinar, and don't forget 5 stars are the best recension and 1 is bad. And yeah, that's all. Thank you for your attention and have a nice day, and we see us again. Bye.
Thank you. Have a nice day. Ciao.